you guys, we're excited. We're learning about atmospheric pressure today. And I'm here with Alicia, and she's got this vacuum pump, and it's hooked up to an Erlander flask with some water in it. And Alicia, could you touch that flask? Tell me if the water is cold or hot. She said it's cold. Now, we know that water boils at 212 degrees Fahrenheit or 100 degrees Celsius. But if this water's cold, it shouldn't boil, should it? So we're going to do something with this vacuum pump, and we're going to see how it affects the water. So, Alicia, go ahead and turn on that pump. And let's look at the water. Now remember, boiling is when a liquid turns into a gas. And I'm looking at this flask, and it looks like it's boiling. But it's cold. Alicia, can you touch the flask again? Has it got any warmer to you?
No.
No, it's still cold. Mariah, you're sitting there. Why don't you touch the flask? Mariah, tell the class, is that hot? No, it isn't, but it should be. It should be 212 degrees. Something changed the conditions so that liquid could turn into a gas even though it's not at 212 degrees. What do you think happened? Why is it boiling if it's not 100 degrees Celsius? What's that vacuum pump doing? Is it adding pressure or is it sucking air out? Yeah, it's sucking air out of the flask. And so when you reduce atmospheric pressure, when you take all of the gas out of the flask, you change the boiling point of the liquid. So the temperature at which water boils depends on the atmospheric pressure inside the flask. Less pressure, it boils at a lower temperature. At normal atmospheric pressure, it has to be 212 degrees or 100 degrees Celsius. So, Alicia, go ahead and turn the motor off. Now, Alicia, slowly I want you to undo the cork on the top, and you should hear a pressure change. It's hard to pull off, isn't it? Can you tip it to one side? It's on there really tight because there's a vacuum. Yeah, did you hear that? Yeah, some of that pressure was released and the air went back inside. The atmospheric pressure was equalized from the inside of the flask to the outside of the flask. That was great, Alicia. Thank you. And I'm here with Kyla, and we're back with our vacuum pump, and we want to find out what happens to this balloon when it's hooked up to the vacuum pump. And the essential question in this lab is, what makes the balloon inflate? If no air goes inside the balloon, because you can see it's tied in a knot, and no air comes out of the balloon, then why does the balloon change its shape? Okay, Kyla, turn on the vacuum. Watch the balloon. You guys see the balloon? Okay, stop. Now, no air went inside of it. Why did it inflate? Why did it get bigger? Pressure, okay. Now, Kyla, really slowly tip the cork just a little bit, Kyla. Let's see what happens to the balloon. Let a little air back in. What happens to that balloon? That's because it's pressurized. It's under pressure. Look at that. Look at the balloon. It got small again, but it's tied in a knot. No air came out. No air came in. Let's do it again. All right, Kyla, turn it on. Watch the balloon. I'm going to hold it up. Watch the balloon. Okay, stop. Did we inflate it? Did we blow more air into it? No, it was tied in a knot. Okay. Now this time again, we're going to lift the cork really slowly. We're letting air back in. Why does it get smaller? Look how small it is now. Okay. Is the pressure pushing on the outside of the balloon when I take the cork off? Yes, that's right, Diego. If I let air pressure in the classroom come back into the flask, it's pressing on the balloon and it's making it smaller. If we take all of that pressure out of the flask, then the air molecules that are already in the balloon, they can expand. So I'm not adding air to the balloon. I'm just allowing the molecules that are already in there to expand. Way to go, Kyla. Thanks for your help. And I'm back with Alex and our vacuum pump. Alex, what did we put in the Erlander flask? What's in there? Yeah, we put some marshmallows inside. We want to find out what happens to a marshmallow when it's hooked up to a vacuum pump. And we've got the top sealed. Okay, Alex, flip on the pump. Let's see what happens. Watch the marshmallows. Looks like they're changing. Okay, flip it off. Okay, and let's see what happens when we release the top, the cork here. Oh, now look at our poor shriveled marshmallows. That's the difference when they've been jet puffed and when they're not jet puffed. I think we took all the puff out of the marshmallow. Let's have some of these come out and see if they taste any different. Does anyone want to try a shriveled? You want to try a shriveled marshmallow? They look awful. They really do look terrible. Gabby, you want to try one? Come on up here. Okay. Yeah, come on up here, Ava, and come on up here, Alacia. Try one of these shriveled marshmallows. Tell us if they taste any different. Any difference? They taste a little different? Okay. Amani, try it out. Does it taste any different?
It's more dry.
It's dry.
It does.
Oh, yeah, it feels a little heavier, maybe a little denser because there's no air that's puffed into it. Marshmallows in a vacuum pump.